The Milky Way, our cosmic home. The Milky Way, our galaxy, is a vast and awe-inspiring structure that stretches across the night sky, dominating our perception of the universe. It is home to billions of stars, planets, nebulae, black holes, and countless other cosmic wonders. As our cosmic home, it offers both a sense of familiarity and a deep sense of mystery about the origins of the universe and our place within it. This article will explore the structure, history, and significance of the Milky Way Galaxy. From its formation billions of years ago to its eventual collision with the Andromeda Galaxy, the Milky Way provides valuable insights into the workings of the universe and the nature of cosmic evolution. The structure of the Milky Way. The Milky Way is a barred spiral galaxy, characterized by its distinct structure, a central bulge, a flat disk with spiral arms, and an outer halo. Each of these components contributes to the galaxy's overall form and functionality. 1. The galactic center. At the very heart of the Milky Way lies a supermassive black hole known as Sagittarius A star. This black hole, with a mass equivalent to about 4 million suns, is the gravitational anchor that holds the entire galaxy together. Surrounding this black hole is the galactic bulge, a dense region filled with older stars, gas, and dust. The galactic center is located about 26,000 light-years from Earth, and it is a region that is both mysterious and intriguing. The black hole and the surrounding stars and gas exhibit high levels of radiation, and the area is often studied for insights into the behavior of supermassive black holes. 2. The galactic disk and spiral arms. The Milky Way's disk is where the majority of its stars, including our Sun, reside. It is a relatively flat, rotating structure that contains stars, gas clouds, and dust. The spiral arms of the galaxy, which are visible from Earth, contain a large concentration of young stars and are the regions where new stars are being born. The Milky Way's spiral structure is not perfect, but exhibits a pattern of winding arms. These spiral arms are areas of higher stellar density, and the Sun lies in one of them, known as the Orion Arm or the local spur. These arms are created by the rotation of the galaxy and the density wave theory, which explains how stars and other matter move through these regions. The disk also contains large molecular clouds, which are regions of space where new stars are born. The gas and dust in these clouds collapse under gravity, leading to the formation of new stellar objects. This process, known as star formation, is a continual cycle that fuels the galaxy's growth and evolution. 3. The halo. The galactic halo is a roughly spherical region surrounding the disk of the Milky Way. This area contains older stars, globular clusters, and dark matter. The halo is thought to extend far beyond the visible disk of the galaxy and includes a significant amount of invisible mass, dark matter, that influences the galaxy's overall gravitational dynamics. Dark matter, which cannot be seen directly but is inferred from its gravitational effects on visible matter, is thought to constitute a significant portion of the Milky Way's total mass. This mysterious substance remains one of the most intriguing aspects of galactic physics. 4. The galactic spheres. In addition to the visible stars and nebulae, the Milky Way is also home to vast amounts of dark matter. This enigmatic substance does not emit, absorb, or reflect light, making it impossible to detect directly. However, its presence is inferred by its gravitational effects on visible matter, particularly stars and galaxies. The outer halo of the Milky Way, which contains the dark matter, is often referred to as the dark matter halo. This structure extends well beyond the visible edges of the galaxy and plays a crucial role in the galaxy's formation and behavior. The formation and evolution of the Milky Way. The Milky Way is thought to have formed roughly 13.6 billion years ago, shortly after the Big Bang. The process of galaxy formation is complex and not fully understood, but astronomers believe that the Milky Way grew through a series of accretion events where smaller galaxies merged and combined over time. 1. Early history, from gas clouds to stars. The first stage of the Milky Way's formation began when gas clouds in the early universe began to collapse under their own gravity. This process triggered the formation of the first stars, which would go on to form the nucleus of what would become the Milky Way Galaxy. These early stars were composed primarily of hydrogen and helium, the lightest elements formed during the Big Bang. As these first-generation stars lived and died, they expelled heavier elements like carbon, oxygen, and nitrogen into the surrounding gas. This process of stellar nucleosynthesis enriched the interstellar medium, providing the raw materials for the formation of later generations of stars and planetary systems, including our own solar system. 2. Galactic mergers and growth. Throughout its history, the Milky Way has likely undergone numerous mergers with smaller galaxies, a process that is common in the evolution of large galaxies. These mergers have shaped the structure of the Milky Way, contributing to the formation of its spiral arms, bulge, and halo. In particular, the Milky Way's halo is thought to have formed from the remains of smaller galaxies that were absorbed by the larger galaxy over time. These mergers have also played a key role in the formation of the galaxy's supermassive black hole at its center, as well as the development of its dark matter halo. 3. The role of dark matter. Dark matter has played a crucial role in the formation and evolution of the Milky Way. It is thought to have provided the gravitational foundation for the formation of the galaxy, helping to pull together the gas and dust that would eventually become stars and other cosmic objects. Without dark matter, it is likely that the Milky Way would not have formed in its current shape. The nature of dark matter is still one of the most significant unsolved mysteries in astrophysics. Although scientists cannot observe dark matter directly, its presence is inferred by its gravitational influence on visible matter. Dark matter is thought to make up roughly 85% of the mass of the Milky Way and most of the mass in the universe as a whole. 4. The future of the Milky Way. The Milky Way is far from static. Over the next several billion years, the galaxy will continue to evolve. The most significant event on the horizon is the eventual collision with the Andromeda Galaxy, which is on a collision course with the Milky Way. In about 4.5 billion years, the Milky Way and Andromeda will collide, likely triggering a series of dramatic events. While individual stars are unlikely to collide due to the vast distances between them, the gravitational interactions between the two galaxies will likely result in the formation of new stars and the eventual reshaping of both galaxies into a single, larger elliptical galaxy. This collision will also likely cause the supermassive black holes at the centers of both galaxies to merge, creating a larger, more powerful black hole. The Milky Way and human culture. The Milky Way has long captured the imagination of humanity. Its presence in the night sky has inspired countless myths, stories, and works of art. In many ancient cultures, the Milky Way was thought to be a river of stars, a bridge between the earth and the heavens, or even a celestial pathway for the souls of the dead. In Greek mythology, the Milky Way was created when the goddess Hera spilled her milk while breastfeeding Heracles. In Native American cultures, the Milky Way is often seen as a spiritual path, guiding souls to the afterlife. 1. The Milky Way in modern astronomy. In modern times, the Milky Way has been a key subject of study for astronomers. Our understanding of the galaxy has grown tremendously over the past century, thanks to the development of powerful telescopes and advanced observational techniques. The discovery that the Milky Way is just one of many galaxies in the universe marked a paradigm shift in our understanding of the cosmos. It was once believed that the Milky Way was the entire universe. However, in the early 20th century, astronomers like Edwin Hubble showed that the Milky Way is only one of billions of galaxies that populate the universe. 2. The search for extraterrestrial life. One of the most profound questions in modern astronomy is whether or not we are alone in the galaxy. Given the vast number of stars in the Milky Way, estimated to be around 100 billion, it is reasonable to assume that many of them have planets orbiting them, some of which may be in the habitable zone, where life could potentially exist. Efforts to find extraterrestrial life have intensified in recent years, with missions like the Kepler Space Telescope and the James Webb Space Telescope searching for exoplanets in the Milky Way that may have conditions suitable for life. Although no definitive evidence of extraterrestrial life has been found yet, the discovery of thousands of exoplanets has opened up new possibilities for the existence of life beyond Earth. Conclusion: the Milky Way is a cosmic wonder, a vast and complex system that holds our solar system, our planet, and perhaps our very existence within it. From its mysterious center to its sprawling spiral arms, the galaxy offers endless opportunities for exploration and discovery. As we continue to study the Milky Way, we gain not only a deeper understanding of the universe's past and future, but also a greater appreciation for our place in the cosmos. The Milky Way is not just a backdrop to our lives, but an active, evolving entity that continues to shape the universe around us. It is a constant reminder that we are part of something much larger and far more complex than we can fully comprehend.